Graphing standard form equations is a little bit harder than vertex form just because there's more steps to it. So first, let's identify what everything means. So our a value means if it's greater than 0, that it's going to open up. And if it's less than 0, it's going to open down. Our axis of symmetry is x equals negative b over 2a. Our x coordinates are negative b over 2a. And our y coordinates are to plug it back in. We're going to plug the x coordinate in to solve for y. And our y-intercept is our c value. You're not always going to be able to graph your y-intercept, but it's really nice when you can because you know that you have a point on there that's correct. So here are your steps to graphing. Find the vertex, and that's an xy ordered pair. Then step 2 is to graph the y-intercept. And we're going to graph our axis of symmetry, AOS. So again, sometimes you're not going to be able to graph the y-intercept, and that's okay. You can always graph the axis of symmetry, though. So then we want one point to the right. After our one point to the right, we're going to reflect it. Then we're going to do 2 to the right. And we're going to reflect it also. Okay, so those are your 6 steps to solving this. So let's look at an example. So here's our first example. Okay, so the first thing that you need to do is find your vertex. So remember, in finding your vertex, you're doing negative b over 2a. So the opposite of b, we already have negative 4, so it's the opposite of b to get 4 divided by 2 times 2. So this is 4 over 4, which is 1. So 1 is the first part of our vertex. The other part is to say that the axis of symmetry is at x equals 1. So at x equals 1, we can go ahead and put a dotted line there. That's where the graph's going to fold in half. So to find the rest of your vertex, we're going to plug this back in. So 2 times 1 squared, 4 times 1 minus 2. So that's going to give me 2 minus 4 minus 2, which is negative 4. So the ordered pair of the vertex is 1, negative 4. And you can go ahead and put that ordered pair on your graph. Okay, so in this instance, we are able to graph the y-intercept. Our c value here is negative 2, so it hits the y-axis at negative 2. And y equals negative 2 is right there. That's probably going to end up being one of our reflected points, but that's how we double check to know that it's right. So we want to point to the right. So if our x value starts at 1, a point directly to the right is at x equals 2. And then we're going to want to point 2 to the right. Well, 2 to the right is going to be at x equals 3. Okay, so we started at 1, now we're going to 2 and 3. So we're going to plug 2 into the equation. So y equals 2 times 2 squared, 4 times 2 minus 2. So this is 2 times 4 minus 8 minus 2. So 8 minus 8 minus 2 is negative 2. So my first point to the right is 2, negative 2. So I graph that over 2 and down 2. Okay, when you're reflecting it, you're saying, how far away from the dotted line am I? Well, I'm 1 away. So I'm going to go 1 away on this side, and it happens to be the point that is our y-intercept, so we know that we're right. And that's not always going to be the case. So this is over 0 and down 2 is our reflected point. Okay, so now we're going to plug in x equals 3. So we have y equals 2 times 3 squared, 4 times 3 minus 2. So this is 2 times 9 minus 12 minus 2. So 18 minus 12 minus 2 is going to give us 4. So this point 2 to the right is 3, 4. So over 3 and up 4. Okay, if I want to reflect that, I'm saying, how far away am I? Well, I'm 2 away, so I need to go 2 away on this side, and that's going to give me negative 1, 4. The last step to this is you connect your dots. You have to connect these, you have to put arrows on the end. This makes a parabola. Okay, and that's how you graph in standard form. So let's look at a couple more of these. All right, our first one here. Finding our vertex first. Same formula, negative b over 2a. So we already have negative 6, so it's going to be positive 6 divided by 2 times 1. So that's 6 over 2, which is 3. So 3 is the first part of our vertex, and 3 is our axis of symmetry. So I can go ahead and put my dotted line on here. Okay, so now I want to plug that back in. So I'm doing 3 squared, 6 times 3 plus 12. So 9 minus 18 plus 12, which is also going to give me 3, meaning that the vertex is 3, 3. So I graph that over 3 and up 3. I also want to look for my y-intercept. In this case, the y-intercept is at y equals 12, which is not on our graph. And that's okay. We know what it is. We know that it should be high up there. So we can kind of just guess and check based on our graph. So now plug in a point to the right. So if we started at 3, the point directly to the right of that is at x equals 4. So now we're plugging x equals 4 into the equation. So 4 squared, 6 times 4, and 12. So 16 minus 24 plus 12 is 4. So that's the ordered pair 4, 4. So I graph that, go over 4, up 4. To reflect that point, I say, okay, I'm 1 away from the axis of symmetry. I'm going to go 1 away from the axis of symmetry here. And that's the point 2, 4. Now I want to do a point 2 to the right. Well, if we start at 3, 1, 2 takes us to x equals 5. So you're plugging 5 into this equation now. So you have 5 squared minus 6 times 5 plus 12. And that is going to give you 25 minus 30 plus 12. And that's going to give you 7. So this is the point we plugged in 5. We got back 7. So over 5, up 7. And I say, how far away am I? I'm 2 away. So I need to go 2 away on this side. So that's the point over 1 and up 7. Last thing we need to do is connect our dots. Make sure that you're, missed there. Make sure that you're making it U-shaped. You're not making a V, because a V is an absolute value graph. And this is quadratic. This is what a parabola looks like. Okay, and then our last one over here. This one does not have a value for C, so you can add a 0 onto the end to it if you want to. So negative b over 2a for the vertex, just like always, is going to be negative 4 divided by 2 times 2. Well, negative 4 divided by 4 is negative 1. So the first part of our vertex is negative 1, and the axis of symmetry is at x equals negative 1. So we put our dotted line there. We plug this back in to see what the rest of it is. So 2 times negative 1 squared and 4 times negative 1. Well, that's going to give me 2 minus 4, which is negative 2. So my vertex is negative 1, negative 2. Plot that on my graph. My y-intercept on this, there is no c value, so it's at y equals 0. Well, that's a place that you can graph. The y-axis at 0 is right here. Okay, so we want to point 1 to the right. So if we started at negative 1, 1 to the right is at x equals 0. So this is kind of common sense, but you can also plug it back in to check it. So 2 times 0 squared and 4 times 0 is just going to give you 0. So 1 point to the right is 0, 0, which is already on our graph. That's our green dot. So I say I need to reflect it. I'm 1 away, so I'm going to go 1 away over here, which is the point negative 2, 0. Then I need a point 2 to the right. So if we started here, 1, 2 gives us x equals 1. So you're going to plug x equals 1 into the equation now. And I have 2 times 1 squared and 4 times 1. So that's 2 plus 4, which is 6. So how we write that ordered pair is I plugged in 1, I got back 6. So I go to the point 1, 6. I reflect that by saying, okay, I'm 2 away. I'm going to go 2 away over here. And that's the point negative 3, 6. Last step then is to make your U-shaped graph and put arrows on the end of that. And that's how you graph in standard form.